Our next presenter is joining us from Michigan State University. Dr. Manny Singh is an associate professor of cropping systems in the Department of Plant, Soil, and Microbial Sciences at Michigan State. His research, extension, and teaching program at MSU focuses on current and emerging issues in cropping systems of Michigan, with an overall goal to improve the productivity, profitability, and resiliency of these systems. So we're grateful to have Dr. Singh with us today to talk about managing ear rots in corn and mycotoxins in corn silage.
All right. Thanks, Stephanie. How's everyone doing? Good? All right. Have had good meetings so far? Yeah? All right. I'm glad you said I'm from Michigan State. I have an 8-year-old daughter. She won't let me call just Michigan. It's like Michigan State without Michigan. So that's a big deal in our household. The school down the road, I think it's up north for you guys, right? That's one thing we have common, someone we can hate together, right? All right. So again, I was asked to talk about mycotoxin issues. Focus more on silage corn. As was told, I do work across crops. We do a lot of work in corn, soybean, winter wheat. I have been here a few times. I believe this is my third or maybe fourth time over the last 7, 8 years. So really appreciate the invite. Always glad to be here and interact with you folks, right? Again, I'll show you a few slides, I tend to talk a lot. I think I have an hour, right? I'm going to try to finish within time. But yeah, I'm looking for feedback. I'm showing you some data, but I'm looking for some feedback on what you all have seen around here in terms of this specific issue, right? We started working on mycotoxins 7, 8 years ago. It has been one of those issues. 2016 was the first year we worked on this, and our corn growers were telling us that was a bad year. Then 2017 was nothing there. 2018, we had another flare up. And then we had a couple of sort of quiet years. And then 2023 happened. I think that was a sort of a banner year probably for some of the folks around here as well, right? So this has been something, that comes and goes. As a researcher, I would love to work more on these issues, that are a little bit more complicated. But the reality is, when you put plots out there, as the last speaker was talking about, the conditions, are not as conducive, which is a good thing for a grower, right? I don't want to have my grower face these issues, but if I'm a researcher, I do want to see something in the field. So again, we'll talk about that piece here. Environment, weather conditions of all the variables are one of the main driver factors here, right? So again, let's start with silage corn. And you can see I'm using the word silage corn. Can anyone tell me what's corn silage, what's silage corn? We always have that debate, what should we call it? And we go with silage corn. Because what is corn silage? Silage corn is what you grow in the field, right? Just like grain corn. You put it in to inside, what comes out is what we call corn silage. That's again sort of, our spin on these words. How many of you are growing silage? Few, I see few hands here, right? So again, in terms of when we're thinking about silage corn, what are we thinking? If I were to ask you, what are you looking for in a good silage corn, or again, eventually corn silage? What would be your answer? Tonnage, and I'm glad you said quality, right? When we think about grain corn, it's all about bushels. It's all about tonnage, right? But for silage, that's still there, right? Tonnage, again, it depends on how much area you have, how much feed you can produce. Some people, that's probably more important than quality. But all these quality parameters, that are still there, right? We want high energy, and that's, again, mostly coming from high starch. So we still want plenty of grain in there, right? But we want to make sure that the fiber that we have has high digestibility, we have high protein content, we have the optimal moisture for ensiling conditions, and so forth. I'm not a forest specialist. I do work with our forest people. We have a really good team to make this thing work. But sort of, when I think about this, we use sort of this quadrant, high quality on the x-axis, high tonnage on the y-axis. You want to be in that high tonnage, high quality quadrant, right? If you're not in that, you at least, again, want either high quality or high tonnage. You don't want to be in this bottom left quadrant, right? Low tonnage, low quality. So these things are still very critical, right? And that's what we typically think about when thinking about silage, right? But again, this mycotoxin issue, again, as I was talking, has been flaring up, where our weather conditions are going, some of the recent trends, that's something we need to keep an eye on, right? So let's talk about that. What are these things? How many of you have heard about mycotoxins? How many of you have had issues at your farm? Okay, so I'm in the right audience here. It looks like you guys have had these challenges, right? So what are mycotoxins, right? Again, these are again sort of these secondary chemicals that these various fungal species produce sort of as a defense mechanism. Again, there's multiple ways, we can think about it. But again, these various fungal species that cause these various ear or stalk rots, right? When we're talking about grain, again, we are generally thinking only ear rots. But in silage, we are looking at the whole plant, right? So not only ear, but stalk rot also becomes important, right? And we'll talk more about that in a minute. So what kind of a deal, right? What, why do I care if I have these toxins? And you all are probably aware, right? It does impact the animal performance multiple ways, right? Feed refusals, various hormonal imbalances can cause this accumulation of fluids, really can negatively impact the performance of the animal, including potential death, right? And the challenge is a lot of these can be hidden. When we take our grain to an elevator, it does get tested for some of these toxins, right? And we, as a severe case, we can get price docking. But with silage, since it does not go through official marketing channel, these issues might get unnoticed, right? That's one of the limitations we have seen with our growers, that I might have these issues, but I just don't know about it because I did not test. And I didn't think that was the limitation I had in my operations, right? So again, here are some levels, some of these different mycotoxins. Don deoxynivalenol are commonly referred to as worm because animals vomit if diet has high levels of these, right? Zearalenone is another one. Fumonisin is another one. We'll talk about the fungal species that do produce these. You can see some of these levels here. This is based on a study from Wisconsin using 50% diet ration, right? And you can see these numbers vary between dairy cattle, swine, and poultry. These are, again, sort of thresholds. We don't have actual actionable or advisory levels on these mycotoxins, unlike we do have those for grain, right? FDA has those levels. On the silage side, we don't. And on the grain side, they do vary. Like for Dawn, it's anywhere from 5 to 10 ppm. So for silage, these thresholds are relatively very low, right? You can see a 1 ppm or even less than a half ppm in some of these cases, right? So again, there is still a lot we are trying to learn what are the consequences, right, of individual toxins as well as their co-occurrence, because chances are if we are getting one of these, we have multiple others out there. So what are those potential implications, right? And again, to me as an agronomist, my go-to deal is whatever we can do to minimize them from occurring at the first place when the crop is growing in field is what we want to go, right? Less is better, no is even better. All right, so let's look at a couple of these fungal species and the toxins they are producing, right? This Gibberella ear rot, also called Fusarium ear rot, it's the most common one. You can probably, most of you have seen this if you have had these issues in your field. This pinkish looking mold often begins at the ear tip, and that's the one that's, again, most common, produce this Dawn mycotoxin as well as zearalenone. This one does prefer cool and wet conditions. So cool temperatures and wet conditions during that silking time, that's where the infection starts to occur. The other one we have seen in our fields is the Fusarium or stalk rot. You can see it looks a little different, right? More of this whitish looking mold, the starburst pattern on these ears. So a little bit different, produce fumonisin. This one does prefer a little bit moderate temperatures, but still wet conditions. These are the two main ones that we have seen in our plots. There are a few other ones. You can see there's aspergillus ear rot. That's more common in southern states. Texas has a huge issue with this. Produce aflatoxins, which are probably the most severe mycotoxin out there. Diplodia ear rot, we have seen these. They don't tend to produce mycotoxin. That's another piece. Just because we see these symptoms in the field does not mean that we are going to get these toxins. And not seeing these in the field, again, does not mean that you won't have toxins. So they can go either way. I'll show you some data, but that's part of the challenge why this problem is so complex, right? Another piece here is that's different between grain and silage is where they're coming from, right? I was talking about ear and stalks. You can see this is some data from Wisconsin where they had these two hybrids. And you can see in hybrid one, the relative proportion of down in ear and stalks was relatively similar. But look at this other hybrid. You had way more toxin levels in grain than in the stalk, right? So again, if I'm going for grain, I probably don't need to worry as much about this issue. But yeah, any toxin coming from the stalk is part of the issue for silage production, right? This is where, again, hybrid selection is, again, very, very critical. All right, so let's think about drivers of mycotoxins, right? Again, it's caused by a disease. So if I were to ask you guys, what are the potential drivers? Anyone remember what are the drivers if a disease is occurring in field? Here's the thing. Anyone remembers the disease triangle back from your biology classes, right? For any disease to occur, we typically are looking at three factors. We need a host that's susceptible to an infection. Then we need a pathogen that's virulent, able to cause infection, right? So generally the driver, as I was talking before, becomes the environment, right? As you were talking. Favorable temperature, cool to moderate, and high moisture, high humidity conditions, right? Around, again, the time when the host is susceptible. And for the most part, a lot of these ear molds, again, are occurring when silking is happening. So during that silking window is where a lot of this infection is occurring, right? So again, timeline of when silking is occurring in the field becomes critical because that's where the favorable environment piece sort of begins, right? So this is what we typically used to think. We have been looking, again, working with our entomologist, Chris DeFonso, that I'm sure some of you have heard from. This other piece, how about insect injury? Especially Western bean cutworm has become sort of an important pest for us. Was not the case 15, 20 years ago. Again, that's causing wounds on those ears, right? And providing another way for those fungal species to get inside, right? And we probably have seen that. You can see over here a wound, and you can see some fusarium right in around that wound. So we have been looking at that piece as well. What are the implications, again, for silage? And this is probably even more relevant on the grain crop side of things because you have longer time, right? After the infection occurs for those toxins to keep accumulating over time. All right, so we're going to come back to that triangle. So again, sort of, to get things going, we were wondering, we were doing some research, but we were wondering what are the issues out in the field, how severe this issue is for some of our growers, because again, lack of testing is part of this, right? So we did this survey pretty much across Michigan counties. You can see a couple where we had quite a few samples. Over 3 years, we did this survey, again, working directly with extension people, getting a sample when a grower was harvesting their silage out in the field. Over 3 years, we collected, I think, at least 150 samples, something around that. In addition to the sample, we did give them a survey sheet to collect additional information, right? Again, to go back to the disease triangle to figure out if we are going to see something, what are the drivers, right? So we did ask for a lot of information, their field history, their management. Have they seen some of these ear molds in their fields previously? All right. So this is sort of, again, was an extensive effort. We did get some interesting data out of this, right? I'm not sure if Ohio has done something like that, but again, that would be something I probably would think of. Here is some data, starting with that dawn mycotoxin, right? Sort of, seeing how it was sort of spread out across all these 3 years. And in all these 3 years, we were collecting these samples. The environmental conditions were not really bad. Like we didn't have a 2018 or a 2023. 2019, 21, we have had those issues, but we didn't have a big, like sort of a flare up. But you can still see that we had a couple of these locations, in the thumb area and out further west where we were getting up to 4 or 5 ppm down levels. And again, we did find these in every single sample we collected. I think we had up to 7 different mycotoxins in every sample we collected. And dawn was in all of them, right? So you can see again, sort of a geographical spread within the state. So we did sort of relate this to, are there reasons behind it? And again, if you know Michigan, you know, like, again, there's a Saginaw Bay here, right? And again, thumb area is generally where we have heard people talk about this. So the environmental conditions, again, those Great Lakes, again, surrounding us are providing some of these environments unique to, again, the thumb area and a little bit in that southwest. Those cool conditions, those, again, high humidity conditions that are leading to these issues. So again, if we have growers in these areas, now we can tell them that be aware of this. Compared to a farm in the middle part of the state, out here, I have a higher risk of some of these toxin issues. So I want to make sure that you guys are testing your samples, right? So again, that was something we learned from this survey. Again, some other toxins you can see, zearalenone, again, we had a higher level in that thumb region, again, of all the regions. Fumonisin, again, same issue. You can see in that tip of the thumb area, we had high levels of this toxin, right? So this was sort of very informative to us. Yes, sir. No, this is all silage. The data I'm showing you today is mostly focused on silage. We did do some surveys, more from research perspective. We had these corn hybrid performance trials like you guys have. So I do have some of those data, but yeah, this was directly working with silage on farm. There, like, this is not research samples. This is coming directly from farmer fields. And please feel free to ask any questions as we go through these slides. All right, so that was one thing we learned here, right? Another thing we learned here again, we're talking about these 2 or 3 different toxins, right? But we did found quite a few other toxins out there, right? What does that mean? I still don't know, but yeah, this co-occurrence phenomena is relevant, it's out there. And you can see a lot of relations between these toxins, right? Dawn is here. There are some other derivatives of dawn, zearalenone, couple of fumonisin species. And as you come down, you can see this T2 toxin that has been showing up now lately as well. So again, I think it's part of the process, just because it's there, shall I be worried? And I still don't know the answer to that, right? Some of the concentrations of these toxins were relatively low, but they were out there. What are the implications on animal performance? Again, that's where I think our animal scientists need to be spending more time looking at this issue of co-occurrence. But yeah, again, whatever we can do to minimize these issues is going to be helpful. And we did see some sort of, again, the idea was, can we use, like, let's say dawn as a proxy to estimate, is there's something else out there? Because testing for these is not cheap, right? If you have done that. So we have been looking at some ways to sort of quantify, going by 1 or maybe 2 toxins and see, can we use that to estimate what else might be out there? Fortunately, again, aflatoxin we did not find. That was, I think we had the lab we were working with were looking at 26 different toxins. And they found everything except aflatoxin. So again, that's a good news here, right? That toxin, again, is more dominant in the south. The fungal species does require hot conditions. So we have not seen that, at least in our samples. So again, part of the survey, as I was talking, we were asking people, give us more information. So if we are seeing these toxins, we can figure out where they are coming from. We did collect, again, a lot of those data of all the variables, crop rotation and planting date. Those were the 2 variables that explained for dawn up to 90% of variability in our samples. And even for fumonisin, up to 70% or so. So those were the two that we really found that they were drivers for some of these farmers. Tillage was part of it, but it did not show up as significant as these two other factors, okay? Looking at that data again, one would expect that, again, for all, at least for Dawn and fumonisin, when we had a non-host crop for these fungal species, right? We have a lot of diversity in Michigan, probably more than for you guys around here, but at least you can see soybeans, dry beans, and sugar beets. When they were part of the rotation, we had a reduction in these toxins. Across, again, all 3 years, we looked at these data always. Also, we did see an impact of planting date. We were sort of surprised by this piece that when our growers were planting in their typical window, again, the idea is that we focus mostly on corn grains, silage. We don't try to focus as much on timely planting. So we have a lot of growers who are planting towards the end of May, even early June. And we saw that, yeah, when we were out in that window of mid to late May, we saw a significant higher levels of both Dawn and fumonisin compared to early planting as well as late planting. That was something that was of surprise to us. And we actually did a lot of follow-up work looking into that, right? That data was coming from, again, on-farm samples. So I think from 2019 through 2022, 4 years, we did this work looking at the planting time piece, right? Again, the challenge with those trials was we didn't really have a year when we had really high toxin levels, okay? But we did look at the data sort of in a similar way as I was showing you in the previous slide. We sort of compare this early to mid to late planting, right? Early, again, is anywhere, think by first week of April, May, and then late is going into end of May, early June. And even here, we can see the number of samples that had higher concentration than 1 ppm was by far the most in that mid-planting window. So we were surprised again, and we're trying to figure out why that was the case. And that comes back to the environment piece, right? Because your planting time drives when the crop is silky, right? So again, that's the optimal window for some of these species to, again, cause infection. And typically what we have seen is that when the corn is silking for us in August, we have a little bit high rainfall amounts, longer term, compared to if it's end of July or early August. Again, that can change based on a given year, right? But again, sort of what we were seeing across all the years we had was if we are planting in that mid window, mid to end of May, the silking is occurring when we have conditions very conducive to fungal growth. When we are able to go for timely planting, we are able to avoid those conditions at the time of silking. That probably helps a little bit with, again, lower infection levels and eventually lower toxin levels. But again, there are multiple other factors, right? Again, mycotoxins is one, as we were talking, overall tonnage and quality. Across the board, we saw that, starting all the way from total tonnage to all the quality parameters, right? Fiber content, digestibility, starch, even looking at the milk per ton. Across the board, we saw that our early or our timely planting, at least in these 2 years, had better tonnage as well as quality, right? So again, it's a win-win scenario that shooting for timely planting did help us reduce some of the mycotoxin issues, as well as did help us improve the tonnage and the quality of it, if that's making sense, right? So again, this all sort of tied up nicely for us based on our survey work, as well as the work we were doing in our small plot work. All right, any questions there? I'm gonna move on to the next one then. Again, when we think about these issues, again, hybrid selection is a main one, right? So we did do this study again over multiple site years, looking at the hybrid selection piece as well as the fungicide application. Within hybrid selection, we did look at the disease ratings, right? Low, medium, high resistance levels. We had a hard time parsing those out. So at least for this talk here, I sort of focused on the insect protection trait within those, okay? You can see a lot of locations we had, a couple of those down south close to you guys here, right? So again, a lot of data here. We did apply proline, prothioconazole at silking time for our fungicide application, right? And then the insect protection piece, again, we went with a non-BT. We do have a lot of organic growths in our area, so we wanted to look at that. And then we compared with, again, sort of these insect traits, right? Cry1F was, again, still on the label back in 2016, even for Western bean cutworm. And it was not even functional. We sort of knew that, so we did work with our entomologists figuring this out. And then we went with this WIP3A trait, right? To look at, again, sort of a more functional trait against Western bean. So this was sort of our three-way comparison looking at the insect piece here. First of all, again, looking at the insect feeding, you will see a lot of data here, but yeah, pretty much what we saw was what we expected. That we did, by using these insect protection traits, we did cut down our insect feeding incidence. That's, again, number of years that had some damage from some of these insects. Mostly Western bean cutworm was our issue. Insect feeding severity, again, that's the number of kernels those insects are chewing on, right? So again, what one would expect. We did see a significant reduction. More so where we were using those two traits, the Cry1 plus the WIP3A compared to just the Cry1. Looking at the ear rot incidence level, we didn't see a whole lot. At least in one location in Wood County, actually around here, we did see a reduction. But the main difference we saw was in the ear rot severity. So again, how many kernels on a given ear were infected by those ear rots, right? And you can see across most of our locations, pretty much on the x-axis, that we did see a significant reduction. Again, more so when we used those two traits, the Cry1 and then the WIP3A. So we did see that significant difference. And it sort of comes down to this, you can see a good relation here. As our ear feeding incidence increased, our ear rot incidence also increased. This relation depends on, again, the environment piece, right? Where, again, the environment is not very conducive to some of these fungal growths, right? That's where this relation is generally more significant. It does contribute, again, having these insect feeding does contribute in terms of creating that favorable environment. But again, is not the main driver. Main driver is, again, those cool and wet conditions that, again, seem to come up and go, based on, again, a given year's weather. But this relation was there in a lot of our site years. When we did look at our, again, mycotoxins, again, that's the end game, right? Here I have some of those data from one of our location, and you can see the dawn levels are on the x-axis. That's the 1 ppm threshold I showed you before. For zearalenone, 0.4 ppm, that's the threshold line, right? So again, here when we used those hybrids with the WIP3A trait, we did see a significant reduction, right? At this location. This is for both dawn and zone. We also did look at the other locations where dawn was pretty much our issue, and you can see a lot of those locations, we did see a reduction in that mycotoxin when we did use that at WIP3A trait, right? And again, if we are causing reduction, is it biologically relevant or not? That's another piece, right? And we did see that we are cutting it from above those thresholds of 1 or 0.4 ppm to below that threshold. So biologically, it is relevant. In some locations, we didn't have high enough levels. If you start with 0.2 ppm, yeah, cutting it down is not as relevant, right? All right, so again, sort of, what I've been showing you, there are relations there, again, just having ear rot does not mean that you are going to get down, right? You can see a couple of data points on this axis. We didn't see any ear rot symptoms, but we still had high dawn levels, right? So that issue is still out there. That's where, again, knowing the field history, testing these silage samples is relatively critical. We also again saw these relations between insect feeding and some of these mycotoxin levels, right? But again, it's not always there. Yes, sir.
Not treated with insecticide 2 times.
Nope, nope. So for this research, all the data I'm presenting for insect protection, we did not use an insecticide. We were just looking at the trait piece. So yeah, for this work, we have not used any insecticide. Because again, we didn't want to conflict anything. We were just looking at the trait piece, right? So again, that's where again, when I talk to our entomologist, she always talks about scouting and spraying. That's the key there, right? Following the optimal IPM, right? You all know that, right? That's again, is the gold standard, but it's not easy to do. We all know that. Scouting again is time consuming. It takes time, right? That's where knowing fields is important, and that's where sort of thinking about using these effective traits against some of these insects is part of the IPM approach, not the starting point, so to speak, right? Environmental conditions is still seems to be the main driver. We have seen again these insect issues creating more challenges, where again during silking time things were looking okay, right? That yeah, we probably won't see anything. But then because of those insect damage, those wounds, later in the season when the conditions became conducive, now I got those issues. So again, what these insect issues are doing is sort of extending the window when the potential ear rot infections can occur, right? That's sort of the add-on piece there. All right. Any questions on that piece? Moving on to the fungicide application again. So we did do this at all of these site years. I think we had total of 14 locations across these years. Out of those, you can see these are the 5 or 6 locations where we did see some differences. When we applied fungicide, at least these 2 locations, Allegan and Lenawee, those were those locations where the driver of this, the mycotoxin issues we have had was not because of any insect feeding. It was just a pure environment, right? There we did see a benefit. Other locations, yeah, we did see some benefits, but it was not as consistent. There were 7 site years where we did not see any difference. So again, fungicide is part of, again, the whole package here, but it's not a silver bullet, so to speak, right? We did see some reductions, and again, in disease levels, in toxins, we did not see any difference in our overall tonnage or our quality parameters. There were, again, some differences in few locations, but yeah, overall tonnage, quality, milk numbers, we have very inconsistent results. And I think the research has shown that, fungicides do help out, but yeah, the conditions have to be right, and the fungicide application has to be right, the timing has to be right, the product has to be right. All those conditions have to be there to really make them work. They are an important tool, but not only a tool to rely on with this issue. All right, one last piece here. Again, it's probably going a little bit beyond mycotoxins, but seeding rate, right? As an agronomist, that's my bread and butter that I always have to do year in, year out, right? So again, we were sort of interested, what are the optimal seeding rates for silage corn? What's the number around here? How many seeds you guys go for silage? 36. Anyone else? About the same? That's spot on. That's what we recommend our farmers. Grain around 34,000, silage a little bit higher, 36 or so. So we did this work again, going all the way from 28 to 46,000. See, are there any implications? Again, not only on yield and tonnage, but some of these mycotoxin issues. One interesting piece, again, actually, in a couple of our locations, as we were pushing to these higher seeding rates, we saw a higher insect feeding. So that was sort of interesting. And we also saw a higher insect, actually ear rot severity, again, when we had these conducive conditions. So that was sort of interesting aspect to us. Again, we tend to push for higher seeding rates, but again, if mycotoxins, ear molds are part of the problem, even insect damage, is part of the issue, something to keep an eye on in terms of not pushing too high towards these seeding rates. But again, here the driver is our tonnage, right? A lot of data on here where again we were regressing our populations on the x-axis against our yield on the y-axis. So what we were just talking about, we found the agronomic optimal is anywhere between 36,000 to 42, somewhere in that range. But again, as we were pushing to these higher seeding rates, we did see a little bit of a higher insect feeding, higher ear molds, mycotoxins not so much. But again, our recommendation is now again to stay close to what we have been recommending people, push it 2 to 4,000 higher compared to what you are doing for your grain to maximize both tonnage and quality, right? We did collect again a lot of data on the nutritive value, right? And again, here the key message is you all probably know that there's a sweet spot, right? As we're pushing to higher seeding rate, the tonnage goes up, but the quality will go down, right? And you can see some of that. As we are going to these higher seeding rates, we are pushing the fiber a little bit high. And then our starch content is a little bit relatively similar. You can see at the highest rate, we did actually bring it down. And then our digestibility actually went down as we went to these really high seeding rates. So again, that's to me, this is the key driver with the seeding rate, your tonnage and quality, finding that sweet spot. And it just seems like, yeah, pushing for too high seeding rate does sort of negate the quality as well as can lead to some of these mycotoxin issues. All right, one last piece. I lied. I thought the seeding rate was the last one. So ensiling, right? Because again, as an agronomist, I focus on growing crops in the field. But ensiling is relatively important piece of it. We did dive a little bit again, working with the forest scientists, thinking about, what sort of density are we achieving or the impact of the density, right? How well tightly packed that silage is, right? Again, there are implications in terms of the quality, right? Because you want oxygen to be out of it. You want low pH conditions, right? All that. We were just interested, what are the implications on mycotoxins? If you have them, when the feed is going into that the silage for ensiling, are they going to stay same, go up or go down? We do have some data here, but the key piece is that either those toxins stayed at the same level or actually they went up if our packing density was relatively low. So somewhere in this right here, I think this is 30 pounds per cubic feet was what my forage person was saying is the optimal. So if we were below that, you can see we had an increase in some of these toxins. And we had some toxins that were not there in the beginning in the unensiled sample that did show up. So again, making sure that ensiling conditions are optimal is a critical piece here. That they won't degrade, but they can actually flare up. So something again to keep in mind. All right, so to again wrap it up, what are we thinking, right? Hybrid selection again, that's number one. That's the most critical piece there, right? I didn't dig too much into again, those hybrid resistance levels, but yeah, that's very, very critical. A lot of seed companies have that right on their seed tag, or you can go online, find that information, right? Low, medium, or high resistance level to some of these toxins. That's very, very critical piece, I believe. I think industry is really moving the needle on that. There are hybrids. I was talking to someone in the room, even here, part of the Ohio performance trials that you can see year in, year out, some hybrids have high levels compared to others. So if this is one of your issue, paying attention there is very critical. Residue management, again, is relatively important. As I was showing you from those on-farm trials data, we did see that crop rotation was an important piece, that if we have had these issues, rotating to non-host crops is relatively important. A lot of our dairy farmers have corn on corn for 2 or even 3 years. So rotating out of corn becomes relatively important, right? Timely planting, as I was showing you, is very critical, not only for mycotoxin, but maintaining high tonnage and its quality as well, right? Managing for uniformity, that's another piece that we did find out. I think that's part of the issue with fungicide application, efficacy of those fungicide applications, right? because you want to be hitting that silking window, right? The timing is very important. And if your stand is not very uniform, you're going to have issues, right? This has been issue even with the wheat, right? Mycotoxin in wheat, getting that same flowering window. So sort of a same concept here, right? Chemistry is very, very important. We have not done work on this, but again, using triazole based products and not some of these strawberry products, right? Headline, as an example, have shown to flare these things up, I believe, at least in winter wheat. So timing and chemistry and managing for uniformity, I think, are very important tools. Even the coverage piece, right? We were using backpack sprays with our research. So that might actually have some implications in terms of getting good coverage on those silks, right? So that's all important there. And then this insect protection, insect control, again, starting with the scouting and spraying, right? And using functional BD traits if this is a really important issue that you have had history of, right? Again, that's probably an important piece going back to that hybrid selection piece, right? And again, sort of harvesting, I think, is important too, that if we have seen these things, especially for corn grain, timely harvesting is very critical. And as we were talking, ensiling, making sure that we are doing a good job with ensiling is relatively important. This is where we typically focus, pre-plant, at plant, in season decisions, right? Or even at harvest. There is probably a piece, post-harvest. Again, I don't have expertise in there, but yeah, I think there are some potential again that if you have these issues, diluting with other, diet that does not have these issues. There are some binders out there in the market. I don't know how efficient they are, but to me, we don't want to be in that bullet, right? We want to make sure that, yeah, we are not allowing these issues to flare up while the crop is growing out in the field. All right. Again, with that, I have a couple of these resources. All the information I'm talking is on our website. If you go there, go to extension, you can see called grain and silage. We typically put all of our information there. I will put this slide deck out there as well. We have published a lot of articles, both extension, research, that all information you can go there to get that. Again, this takes a lot of work. Again, we do work with our pathologists, our entomologists, forage specialists, get this work done. So again, really appreciate all the support. And I believe we have time for maybe a few more questions. All right, I'll come back to, oops. Yeah,
There's a question in the front.
just give me a quick second. All right. Yes, sir. No, that's awesome. Okay, so yeah, we had actually a couple of locations here. The map I was showing you, some of our southwest locations are irrigated. No, we did look at that piece. We didn't see much there.